This DeBacco University video is going to walk you through the necessary steps when it comes to calculating molar mass. All right, if you're interested in going through the proper steps to calculate molar mass, you've got the right video here. You're going to need the chemical formula of what you're trying to calculate for, a periodic table, and a calculator. So if you don't have those ready, you might want to grab those so you can kind of work through some of these examples as I give you the step-by-step guide here. We're going to use water, or H2O, as an example. So be sure you've got the necessary components here. I've given you the chemical formula. Now we're going to go through that process. It can be applied to many, many more molecules following these same guided procedure steps. So first off, the chemical formula. Again, we're starting with a fairly simple one. Water, you want to write down the chemical formula of the compound, H subscript 2 and capital O. That's our first step. Progressing then to our second step, which is to find the atomic masses. You want to look up the atomic masses of each element in the formula on the periodic table. Note, usually it's given as the atomic mass units, or AMUs, which are numerically equivalent to grams per mole for molar mass. So here we see example of hydrogen, dust, carbon there is another example, and oxygen. We're going to focus, because we're looking at water, H2O. We're going to focus on the hydrogen as well as the oxygen in our example here. So step number 3, multiply the atomic mass for each element by the number of times it appears in the formula. So in this simplified example, since we've got 2 hydrogens, I just listed it twice here, and then you get an oxygen. Or you could just do hydrogen times 2 plus the atomic mass here of oxygen. And we're just simply going to basically add all of these together. So step 4 is basically the sum total. So add up all the contributions to get the total molar mass in grams per mole, or abbreviated G over MOL. So the molar mass is this number for hydrogen, 1.00794 times 2, plus the molar mass for oxygen, which would be 15.994. You can see the math here. We add all those together. 18.01528 grams per mole would be our answer for the molar mass of water, H2O. Now, example 2, since if you feel you've got that one, let's go to kind of showing you carbon dioxide here. So we're looking with a couple different elements. Carbon dioxide, CO2. So we have 1 carbon, we've got 2 oxygens. We follow the same basic procedure. Here, rounded up oxygen is an even 16.0, carbon is 12.01. We've got 1 carbon and 2 oxygens, so 16 times 2 plus 12.01 essentially gives us a molar mass of 44.01 grams per mole. And then lastly here, a little more complicated maybe, looking for the molar mass of sodium carbonate, Na2CO3. So the chemical formula for this contains 2 sodiums. We see the subscript goes with the Na, 2 sodium atoms, 1 carbon, and 3 oxygens. So we know the molecular weights for sodium. If we look on the periodic table, 22.98, carbon is 12.011, and oxygen is 16. With those numbers, we need to multiply by the number of atoms present in this molecule. And we go through and do that. There's 2 sodiums, there's 1 carbon and 3 oxygens. We multiply those together. We get our answers. We add all of those 3 components up, and we get the molar mass of sodium carbonate as 105.971 AMU, or atomic mass units. So hopefully if you go through these examples, maybe pause me at certain times, you're able to calculate these on your own for any example element or compound I should give you for calculating the molar mass for.